Hey guys, so today we are going to go over Unit 8, Day 2 notes. And basically, we are going to use the Pythagorean theorem to determine the distance between 2 points, okay? And if you think back to the Pythagorean theorem, that's a squared plus b squared equals c squared. Remember that a and b are the two legs, and the letter c represents the hypotenuse, which is the largest side, and it's the side that's across from the 90-degree angle, okay? So since let's go ahead and do number one. It says find the distance between each pair of points. Round your answer to the nearest tenth if necessary. Okay. So they're basically asking me how long is this line that is made up by these 2 points? Well, of course, some of you may go and say, well, Mr. Gomez, couldn't we just count, diagonally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Well, if you think back to every single math class you've had where you've been dealing with graphs, not one single math teacher has told you that you can count in a diagonal direction. Your teachers have always taught you that you can only count up and down, which is vertical, and left and right, which is horizontal. Just think about an order pair. We always start off by going either left or right, and then the y value will be the up and down direction, okay? So to be able to find this measurement or this distance between those 2 points, I'm going to have to create a right triangle so I can be able to use that Pythagorean theorem, because that theorem only works with a right triangle, okay? So let's go ahead and see if we can create a right triangle. So I'm going to start from this bottom point. I'm going to go up and then over so I can be able to create a right triangle. Now, you might say, well, Mr. Gomez, you can also go down and then over to form a right triangle, and that is correct. It really doesn't matter which one you use because you should get the same answer if you're doing the math correctly, okay? So let's go ahead and start counting our units for those two green segments, okay? That would be 1, 2, 3, 4, 5, 6, 7. So that's 7 units. And then on the other side, 1, 2, 3, 4, 5, 6. 6 units. And then, of course, across from the 90-degree angle is your letter C. And the other two sides are your letters A and B. So what I'm going to do is I'm going to use my theorem. A squared plus B squared equals C squared. So A will be 6 squared plus B, which is 7 squared, equals C squared. And now using decimals, I'm going to square these two numbers and add them together. You're welcome to do that in your head if you want to, because that would be 36 plus 49, okay, after you square. But if you don't, you're welcome to use decimals. So we have 6 square plus 7 square. And we get 85. Equals C squared. Now remember, we're only looking for the letter C, so that means we have to get rid of the square. And the opposite of a square is square root. When you take the square root of a square, they cancel themselves out, and you're left with C equals. And then, of course, you can use decimals to be able to figure out what the square root of 85 is. And that will be 9 point something. 9.2. And it's a round to the nearest tenth. That will be the first decimal place. So that will be 9.2. And there you go. And remember, when I was counting these, we came out with 12 units. You see, the actual distance of this segment was 9.2 units. Okay. Let's look at number 6. Same idea. We're looking for the measurement of this line segment. And of course, I'm going to create a right triangle. So this time, I'm going to go down and over. You could also have gone up and over, but it really doesn't matter. So let's count my units. So that would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I like to double check and make sure I count it correctly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have that. So across from the 90-degree angle is your letter C. The other two sides are A and B. So A squared plus B squared equals C squared. So we have 5 squared plus 5 squared equals C squared. So 5 squared times 5 squared, that will be 25 plus 25 is 50 equals C squared. Okay. And let's figure out the square root, because the opposite of a square is square root, and when you take the square root of a square they cancel themselves out and you're left with C equals, let's see what Desmos tells us for the square root of 50. So the square root of 50 is 7.1, because that 7 will round that 0 to a 1, so it will be 7.1. So that is the measurement or the length of this diagonal, 7.1 units. Okay? And that's what we're doing. We're using the distance formula. Okay, let's move on to the next problem, which is going to be number 1 on the next page. So here we go. What is the distance between the points -6, -7, and 6, -2? So I went ahead and graphed those 2 points right here. And as you can see, there's my diagonal or my line segment between those 2 points. What I'm going to do is I'm going to create a right triangle. Okay. Oop, I went a little bit too far, but it's okay. Okay, so here we go. That will be 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 to 6 is 12, and then 2 to 7 is 5. Okay, perfect. So there's my measurements. Okay, and across from the 90-degree angle is your letter C. So for this one, I'm going to take my picture and place it over here so I can have some room to work it out, and it will be a little bit cleaner to see, okay? So my triangle was something like this, and then we said that this was the letter C, this measurement was 12, this was 5, and we're going to say that this side is A, this side is B. Remember, the letter C is what matters. Across from the 90-degree angle is your letter C. So here we go. A squared plus B squared equals C squared. So that will give me 5 squared plus 12 squared equals C squared. So once again, 5 squared plus 12 squared. Okay. Let's see what we get. So 25 or 5 squared plus 12 squared, that will give me 169 equals C squared. Okay. Then the opposite of a square is square root. So when you take the square of a square root, or you take the square root of a square, they cancel themselves out. So you're left with C equals. And of course, if you do the square root of 169, that is a perfect square. So we should know that the square root of 169 is 13. And so that means the measurement of this diagonal, or this missing side, or the distance between these 2 points, will be 13, which is answer choice D. Okay. The next one we're going to do is number 3. Triangle ABC is a right triangle. What is the length of AC? So AC is right here. So that's what we're going to be looking for. So across from the 90-degree angle is your letter C. And then let's figure out how many units it's from A to B. That will be 1, 2, 3. And then from B to C is 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, perfect. Now, it's kind of hard for me to see the triangle and the graph, so I always like to redraw it really quickly. You don't have to, but I like it that way. So it's your choice. So we have this. So let's go ahead and use our theorem. A squared, we'll say this is A and this is B. So A squared plus B squared equals C squared. So we have 3 squared plus 7 squared equals C squared. So here we go. 3 squared 3 squared plus 7 squared gives me 58. And I'm using decimals on the side, by the way. But I think by this point we all know how to do that, okay? And then the opposite of a square is square root. Okay, and we're left with C equals. Now typically you want to go in there and type in, the square root of 58. Okay, square root of 58. And you get 7.6, okay? But you might say, well, okay, 7.6. Let's look at our answer choices and you go, wait a minute. These are in square root form, which is known as radical form. Okay? So what could be the answer? Actually, we have the answer. We didn't have to go into decimals and type it in. Sometimes the answers will be in decimal form, and sometimes they will be in radical form. This is one of those situations where we didn't have to type it into decimals. The answer was that. They didn't want us to, convert it into a decimal. They just wanted us to leave it like it is. So my answer is the square root of 58, which if we wanted to convert it into a decimal, we know that it becomes 7.61 and so on. Okay? Okay, so number 4. The vertices of a triangle are located at R, S, and T. What is the approximate length of the line segment ST? So I went ahead and graphed those points, and here's my triangle RST. So obviously we are looking for the line segment ST according to the directions. So across from the 90-degree angle is your letter C, and then the other two sides are going to be A and B. So that means I'm going to count the units from R to T, which is 1, 2, 3. So that's going to be letter A. And then from R to S is 5. Let me double check that. 1, 2, 3, 4, 5. And that's going to be the letter B. Now using my theorem, I'm going to find that missing side. Now what I'm going to do is I'm going to take this triangle and copy it over here so I can have some space to work it out. So we have, across from the 90-degree angle is your letter C. This is R, T, S. We said this was 3, which is the letter A, and then this is 5, which will be the letter B in my theorem, okay? So now, A squared plus B squared equals C squared. So that will be 3 squared plus 5 squared equals C squared. Now, 3 squared plus 5 squared should give me 34. Okay? And then the opposite of a square is square root. And so when you take the square root of a square, that cancels out, and you're left with C. Now we're going to use decimals to figure out what the square root of 34 is, which is 5.8, which clearly is answer choice A, which is the missing side, line segment ST. If you have any questions, please let me know by texting me, sending me a message on the Remind app, or sending me an email. Okay?